All right, I'm doing this to talk to you about flip-flops and what's called latches, okay? So um, I want to review the sequential logic and flip-flop because we did flip-flops before, but this is just a review. I'm introduce you to the D flip-flop and provide a table to show that. Also introduce you to the JK flip-flop. It's a different style JK flip-flop, which has basically two inputs instead of one. And then we'll review the flip-flop clock parameters, meaning rising edge, falling edge, those types of things, and also introduce you to the transparent, the D-Latch, the latch, okay, and then just the difference between latches and also flip flops, and then discuss the flip flop asynchronous inputs. Okay, so a definition of a sequential logic is sequential logic can have one or more inputs and one or more outputs. However, the outputs are a function of both the preset value of the inputs and also the previous output value. So it's got memory. Basically, what it's saying, it remembers the last one so it can move on to the next one. The sequential logic requires memory to store the previous outputs. So here we've got our inputs, we've got our clock, which is important, and then we've got our output gates, okay? Here is a D flip-flop, the schematic symbol for D flip-flop. You've got the D, you've got the clock, you've got Q and Q bar. So this is your output. Output is Q. And Q is whatever the Q, and then obviously Q bar is the opposite of whatever Q is. So this is the opposite of the output. So okay, so D is your input. Clock is constantly moving up and down and so forth. So then here we got Q here. We've got our input here, and we've got our clock. Now, if you look at this right here, whatever D is at when the clock has a rising edge, says if I go back here, you see how there's no circle here, so it's the rising edge. If there's a circle here, right at that point there, it would be falling edge. But since there's no, it's on the rising edge, so whatever D is at on the rising edge of the clock, Q is going to go to. So D is at high here, so there. Notice how then now D is at low. Do you see it? It waits until the clock rising edge right there. It goes to high. But now look at how D stays down. It stays down here, stays down here. Now D pops up here, but it doesn't go. Q doesn't go up until the rising edge of the clock. Okay. Now notice how here it goes down and up. Your input goes down and up, but notice how there's no rising edge of the clock in here. Here's a rising edge, and here's a rising edge. There's none. There's none right here, so nothing happens here. Just stays high. Same thing here. It stays high until this point here. It's low here, so it reads it. So whenever the rising edge of the clock, it looks at what D is. And if D is the same as it was before, it stays there. If it's different, it goes back, goes to the other one. All right? It shows that right here. Okay. All right. So this is a JK flip flop. Now, JK flip flops are a little bit different. There's different things you can do. Again, we have the rising edge because the clock, there's no circle there. We've got our J input, our K input. We've got our Q, which is our output, and our Q bar, which is the opposite of the output. Okay. Now, this is the situation. So when J and K are both at 0, it stays the same. It just stays. It doesn't change. So no matter what happens with the clock, the output stays the same. This case here, J is at 0 and K is at high, and on the rising edge of the clock, it clears it. That's a clear. It means whatever it's at, it goes to 0. When J is at 1 and K is at 1, whatever, when the clock rises, whatever Q is at, it goes to 1. So if it's at 1, it stays at 1. If it's at 0, it goes to 0. Now, when J and K both are at 1 or both at high, at the rising edge of the clock, it toggles. So if it's at 1, it switches to 0. If it's at 0, it switches to 1. Okay, that's what toggle means. It just switches back and forth. All right, does that make sense? Hope. And here we've got it. So here we've got J and K are, J is at high, K is at low. The clock rising edge, it sets it at 1. So now here, J and K are both at 1. The rising edge, it just toggles to the next one. Here we've got J at high. Again, it's toggles. It toggles here again because they're both at high right at this point here, at the clock point here. Now the clock rising edge here, it looks here and goes, oh, wait, we got K at high and J at low. Oh, that's a clear, so it's got to clear it back to 0. Here we got 0, 0, so there's no change. Here we've got J at high, K at low. It sets it, so it puts it to 1. And again, we're at 0, 0, so it's no change. So that's the difference between the D and JK flip-flop. Is D, basically, it's whatever D's at happens. JK, you have a lot more things you can actually do with it, okay? Just remember, clock edges is you've got when it goes up from 0 to 1, that's your rising edge. When it goes from 1 to 0, that's your falling edge. So depending on what's going on with the clock, if there's a circle in the front, it's falling edge. If there's no circle in the front by the clock, it's a rising edge. I think the next one's got the difference here. So here we've got, this is a rising positive edge trigger, rising edge. This is the falling edge or the negative edge trigger right here. So this means whenever the clock is going down is when it looks, not when it's going up. Hopefully that makes sense. Same thing with the JK flip-flop. Here we've got triggered by the positive edge, and here we've got triggered by the negative edge. Or the okay, does that make sense? I hope so. Now, with flip-flops, there's generally a little bit of a time gap, a small time gap. So the time interval before the active transition of the clock signal during which the D can manipulate be maintained. There's a little bit. You're not going to notice it really because it's such a small part, but it's not exactly the same time. There's a little bit of a delay, and that's what time hold is and time set is. Okay. Now, asynchronous inputs. There's a preset now with our D flip flops. There's a preset and there's a clear. Okay, since D flip flops don't have the two options like JK does, we've got to have a preset and a flip. Now, if you look at this here, since the circle's there, that means it's active when it's at 0. Okay, so asynchronous inputs have a preset and a clear. So preset means set it to 1. Clear means clear it to 0, put it to 0. Okay, so are used to override the clock data. So and it happens immediately. Right when that happens, it automatically clears. So to preset input forces the output to Q goes to 1 and Q bar goes to 0. The clear sends a Q to 0 and the Q bar to 1. So here we've got on the rising edge of the clock, we've got 1 1 rising edge. We've got Q bar goes to 1, clear preset and clear to 1. When preset and clear are at 1, it just keeps, it's normal. It just runs, switches. Okay, it's just whatever D's at. In this case, D's at 0, so Q goes to 0 on the rising edge. This one here, they're both at 1, so it's running. Basically, that's what it means. When it's high, remember I told you the circle here tells you that it's going to preset at 0. When it goes to 0, it's going to set whatever at that time. It's going to go to 1, and clear means it goes back to 0 at the 0 when it's at low. Okay, so we got a 1 high and high. And D's at 1, so Q goes to 1, Q bar goes to 0. In this situation, it doesn't make a difference what the clock or D's at. In this situation, we've got a 0 preset, so that's going to preset it right over that is. It's automatically at that very second, no matter what the clock's at, it's going to put the Q at 1, and the Q bar goes to 0. Here we've got preset at 1, so preset's not going. There's nothing going on with preset, but 0 goes to, or clear goes to 0. It's going to automatically set at that second, right when that happens, it's going to set the Q to 0 and the Q bar to 1. Now we've got preset both at 0s. It's an illegal condition. You can't have both of them at 0 because it can't put it at 1 and 0 at the same time. It doesn't work that way. So you can't do that. It'll be a legal condition and it wouldn't work. So here's an example of the flip-flop with preset and clear. So here we've got our presets at 1, our clears at 1. So we're running normally. At the rising edge, we've got a high here. So this goes to high. We're still running normal because we're at 1 1 here, rising edge here. So as soon as it rising edge, it looks at what the D's, it looks at the preset and clear. Oh, we're at 1 1, so it's nothing there. But the D went to 0, so move that back to 0. Now here we're moving on. The clock, there's nothing happening with the clock, but notice how the preset went to 0. As soon as the preset went to 0, the Q goes to 1, right at that second. And as long as this stays at 0 here, you stay at the high. And then after it goes back to 1, it waits for the next rising edge of the clock. Okay, and at the rising edge of the clock, you see we're at 1 1 here, so that means there's nothing going on there, but we're at low there, so it's going to send it to low. Then we come over here, we got the rising edge of the clock here. See what we got, D high, we got 1 1, so we're fine. Go to high, and now we move over here. Oh, look here, clear drop down here. So all of a sudden now it's got to drop down because automatically at that second, right when that happens, it automatically goes to clear. And then what happened here, it goes back to high here, but notice how it did not switch here. It doesn't switch until the next rising edge. So here's the rising edge here. We got 1 1 there. Okay, now look at what the D is. We're at high, so go to high and so forth. Okay, and this kind of shows you that what I just went through. Okay. All right, so here we've got our latch. Now the latch, the only difference between the latch and the a regular D flip-flop is you've got an engage. Instead of a clock, you're just having a switch or something else turning the EN, which would be the clock, on and off. Okay, so it's a D-Latch right here. So instead of having a clock, you have an enable. Okay, so here when enable's at 0, It doesn't make a difference what D's at. Q is going to be whatever Q is, and Q bar is going to stay with whatever it was. So it's going to stay with the same. When engage goes to 1, we're at 0 here, then it looks and goes, okay, we go to 0. And the Q bar goes to 1. When the engage is at 1 and D's at 1, it goes to 1 and 0. Okay, here's what we're talking about here. So here we've got the engage. We're at 0 here. So D's at 1, doesn't care. It stays the same. Latches stays there. But now here, as soon as engage goes up and D goes up, now Q goes to 1. Now you'll see we've dropped down here. Engage is still on. So basically what happens is gauge means this. As long as it's engaged, it's on. So whatever happens with D, if D goes to 1, Q goes to 1. If D goes to 0, Q goes to 0. And Q bar goes to 1. It switches. Q bar and Q are the opposite, okay? But now when engage is off, nothing happens. It just stays the same. It's latched. Does that make sense? So when engage is on, whatever happens with D automatically happens to Q. When engage is off, so basically think of it like this. The engage is like a switch. It turns it on and off, okay? So you can see right here, engage is on, D goes off, Q goes off. Q goes on, then Q goes off, D goes off, Q goes off, and then we've got our, the engage goes off here and it just stays at that location until engage goes back on and then just keeps doing that. Hopefully that makes sense. Okay, the primary difference between a D flip-flop and a D latch is the encoder versus the clock input. The flip-flop's clock input is edge sensitive, so it only happens when either the rising edge or the falling edge, depending on which type of flip-flop it is. So flip-flop's output changes on the rising edge or the falling edge of the clock. With an engage, it only changes when the engage is on. So the EN input is level sensitive, meaning the latch output changes on the level high or low of the engage input. Okay. Here are the flip-flops and latches, the parts. So it's a 74LS 74N. That's your latch. You can see this is a negative, so preset and clear. So when it's at high, nothing happens. It just runs normally. When it goes to 0, it actually changes the preset or the clear. Okay, so it's dual positive edge triggered D flip flop with preset clear and complementary outputs. Complementary outputs means you've got a Q and a Q bar. Then you've got your dual, this 74LS76 is your JK flip flop. So it's a dual edge triggered JK flip flop with preset and clear and complementary outputs. So complementary outputs, same. So it's very similar, except this one, do you see this right here? Negatively triggered. I'm sorry, let me show you on this one here. This is negatively triggered. Since there's a circle there, it's negatively triggered. There's no circle there, it's positive. Then here's your 74LS75, which is your quad latch. In this case, quad because we've got a Q and a Q bar, and then we've got a Q2 and a Q2 bar. Okay, you can see the circle here by the Q bar that tells you it's going to be a negative. And then we've got our D input, D1 input, D2 input. Then we've got our engaged. So basically, when the engage is on, whatever's happening to these two, this one here goes to the Q1, this one here goes to the Q2. Here's the 74LS 74 flip-flop. Here's the connecting diagram right here. You get your VCC, you've got your ground at pin 7, VCC is pin 14. We've got a clear, pin 1. And now if you look here, there's actually 2 flip-flops in this chip. You've got to follow this carefully. So here's your clear, here's your D, then here's your clock right here. This 3 is clock, 4 is your preset, 5 is the Q output, and then 6 is Q output, Q bar output. And then here's ground. Then over here is your second flip-flop. Okay, so here's your Q bar, here's Q, here's preset, here's the clock, here's the pin 12 is D2, the second in, and then clear 2 is over here in VCC. And that's the connection diagram for the D flip-flop. Here's a JK flip-flop. You can see that. I'm not going to go through them all this time. And this time you can see the JK flip-flop. Do you see the circle there? What does that mean? Negatively triggered, right? Negatively triggered. That's what the circle means there. The circle here and the preset in this, I'm sorry, on the, what is this one? This was the clear and the preset is only triggered when it goes to 0 since there's a circle there. If there wasn't a circle, it would be triggered on 1. And when it's at 0, it would run normally. Again, we have 2 JK flip-flops in this one chip. But this one's a little different. You see the ground and the VCC. Ground is at pin 13. VCC is at pin 5. So you got to be careful and look at the diagrams. Like we had issues with the what was it, the NOR gate, right? That's where people messed up on the NOR gates. Okay, so here's a D-Latch. We've got 4 D-Latches in this one chip. You can see all the different ones. There's Q1, D1, D2, enable. This is, so there's, again, there's two in each one, okay? You kind of see what it is. This enable here goes to these flip-flops. Where's the other enable? And the enable up here goes to these 2 flip-flops. You got to be careful with that when you're reading those. And that is it. Let me know if you have any questions. I hope this is understandable.